Hey guys, I am Advait.
I am Rachit.
And I am Vraj, and we are going to explain what is web development.
We will clear 6 critical areas of web development which together form a complete web development stack. That means we start with user interfaces which are made in front-end code. We will talk about API and how data gets transferred over network. We will touch on back-end and databases, security and hardware service, RON and modern cloud computing.
But before that, we will look at how web development has evolved over the past 20 or so years. We'll start with the Web 1.0, the era of static web pages that essentially just displayed information. We had the .com bubble, Steinfeld, AOL, and a lot of web pages that looked like this. In other words, they were very useful. In the mid to late 2000s, Web 2.0, the era of dynamic web apps, started to emerge. Web apps are usually characterized by user-generated content, push notifications, and all other things. Now many believe we are entering a third new era, customized AI-driven experiences that are different for every user. Two examples are YouTube recommendation algorithm as well as Amazon knowing what we want to buy more than we do. These advances have blurred the lines between web development and the rest of software development.
Let's dive into our stack starting with front-end. Notably, this is what the user sees and interacts with directly. It's the portal from our app to the outside world. Everyone is familiar with the front-end trinity, namely HTML, CSS and JavaScript. It all starts in the browser when you visit a URL. This will kick off a request for index.html. An HTML file is only made up of two things, text and more importantly, tags. These tags we can modify text, add links, break out pages into sections, and add the classes that we can apply styles to. We also have standalone tags, essentially that tell the browser to load additional assets, whether that's an image or additional files. One such additional file might be a CSS file, which creates an additional request of Google servers, and we receive it all scanned through and load HTML and add styling. This is done through selectors and attributes. Selectors find elements and keep you broad searching for all matching a tag or narrow with a class or ID. Attributes are the styles we apply. Here's some examples. Something nerve-wracking for all people learning CSS is how to do spacing. You can do 95% of your spacing if you master something called flexbox. CSS isn't logical, it's mostly practicing, memorizing and applying what you have learned.
Back to our HTML file, there's one more important fact that we need to talk about. It's the script tag, which allows us to load JavaScript files from a server or elsewhere on the internet. But the way servers that send kinds of files we are talking about are generally referred to as web servers. So, when we see a script tag, we request our file and it gets sent over. Let's look at some of the stuff JavaScript is responsible for with an example. Let's say we have a button tag logs us in. What triggers the login is known as user event, or click on the button to respond to this event. We need what's known as a listener, some code that waits for the button to be led and responds accordingly. When the click happens, JavaScript can update our HTML to show a loader. So JavaScript would update the appearance of a page. We then send this login data to our server to validate it.
Today, almost all front-end developers are using frameworks. Here are some frameworks ranked from easy to hard to learn. And here is them ranked by usage. These frameworks don't do anything that JavaScript can't do. But they gave us a better developer experience, which when you're making changes or fixing bugs is pretty much everything that being said. Browsers can only run JavaScript, not framework code. So a framework code has to go through a build or bundle step which converts it to normal JavaScript. The important part is to choose one and stick with it, although keeping in mind that React and Angular have an order of magnitude more jobs than the other two.
Okay, we have our front end, but how does it talk to the back end? That's the purpose of an API. Essentially, a front end or a back end may or may not be in different languages. So how do we standardize a way for these two to talk? Well, we do that with what's called an API. Most commonly, REST API are used which follow the convention of combining a verb with a location. For example, we might want to get a list of accounts or add a new account. Alternatively, if we pass a parameter, we could get a specific count, modify it or delete it. REST does give us some nice standard, but there is no guarantees. If anything changes, the front end can get messed up. So there is an alternative called RPC which sets rules in advance with something called schema. This makes inputs and outputs explicit in advance.
Now, how is data transferred? Well, that's done most commonly by sending strings back and forth through a protocol known as HTTP. Can be read by any e-programming language. Two common formats are JSON and XML, and we convert data to JSON string through a process called serialization.
So web development backends. Our backend application layer can glue together multiple different components. We can talk to front ends, other servers, and databases. You can write backends in pretty much any language, but the most popular are Python, JavaScript, PHP, and C#. Backend frameworks are commonplace too, to make your life easier. And here's the most common one for each language I mentioned. If you are wondering when we would talk to other servers, backends are often broken into what's known as services. This is just a pattern to separate logic that make things easier to scale and to work on. Other than responding to APIs, backend might do various other batch processes which are often done on a timer. One example of this could be web scraping. To talk to databases, backends often use what's known as an ORM. This just gives us more semantic ways to query our database, add to it, and so on.
Let's talk about databases on a high level. There are two main types of multifunctional databases, namely SQL and NoSQL. They provide different strength guarantees. SQL databases are organized in a script column representation format. That means to write or add to a database. But you have to adhere to the rules of set of rules or it won't work. These strict rules allow you to do more complicated things when you are reading your database. Alternatively, NoSQL databases don't really have rules pages, have collections which are groups of objects. So a user might have a name and email, but it's not enforced. This scale is much better, but you have to be careful because there are no guarantees about the structure of your data. Again, there are many more database principles that apply, and what you use is totally circumstantial. The most popular databases are probably SQL, Postgres, and MongoDB. Finally, you should know that when we try to scale up our application, databases are usually the slowest and they are the bottleneck, and resolving the scaling issues has also entire books written about it.
Let's touch on web security. Any e-web app with a login will need to consider authorization and authentication. The login itself provides authentication. Authentication will usually give the user a string-based token that is a random sequence of characters. This is used on the server side to validate each request. Authorization, on the other hand, defines different user roles. So, I am admin, I would be able to do different things than a normal user. We are almost to the end. Let's touch on infrastructure and networking. Data centers are pretty much where all servers and web servers exist unless you have a dedicated server running at home that's always on. These servers are just computers without monitors that are constantly running. They can be controlled with SSH, a direct way to control the machine from the command line, but most of what they do is automated through scripts. You can group multiple servers into a private network. Each server in a network is called a node, and in private networks, services can be communicated quickly and securely. Servers that talk to the outside world have more to worry about. They are usually set up with a reverse. It's a gateway that exposes specific ports to the outside world. Being a machine, specific address a process is running on. So you might want to expose REST API port but not a database port. Nowadays, most of this hardware management is handled by companies like AWS and DigitalOcean, who run their own data centers and rent out space on demand.
This is where the term cloud computing comes in. You can rent a fraction of a single server for an hourly or monthly cost. Cloud providers like AWS will usually offer a lot of additional services that keep you on their platform. Cloud computing is expand beyond just having servers as a service though. You can run individual functions for a very low cost on demand too. So if I wanted to send an email every time something happened in my front end, I can put that in the cloud function.
Anyways guys, this was all about web development. Hope you understand web development and its components. Please like and share the video so more people can see it, and subscribe for more such content. We will see you in the next video. Stay safe.